Hello, Algebra 1B students. Welcome to part 1 of lesson 11.7. We are going to start graphing rational functions. Earlier in chapter 11, we were dealing with rational equations, rational expressions, where we have polynomials on top of other polynomials. And now we're going to start graphing them, and it's essentially, what we're going to do is essentially like graphing inverse variation, like we were doing in section 11.6, where we have an x on the bottom of a fraction. Okay? And we need to remind ourselves about these things called excluded values. Okay? Part of your practice problems is just going to be reminding yourself what excluded values means. And as a quick reminder, excluded values are points that we are not allowed to put in for x. So they are points where x doesn't work, a certain x value that won't work in these functions. So if, for example, we're looking at the function f of x equals 5 over x minus 2, in order to find the excluded value, I just take the denominator of that fraction and set it equal to 0. Because I know I'm not allowed to divide by 0, I'm not allowed to have that on the bottom of a fraction. So I will put x minus 2 equal to 0, and then x equals 2 is my excluded value, so x cannot equal 2 because x minus 2 is not allowed to equal 0. Okay. Here in part B, it's a very similar idea. Now we have y equals negative 3 over x plus 8. So I just take this x plus 8, and I say that can't equal 0. Well, subtracting 8 from both sides means x cannot be equal to negative 8. That is my excluded value. Okay, so we have these values that make these functions undefined. They make them an error. They make us not be able to do that. And those excluded values actually turn into what are called asymptotes. That's what we're going to talk about now for the remainder of this video, is about asymptotes of certain functions. Okay? So here we can see the examples of two functions that look like inverse variation equations, because this first one is the most basic inverse variation equation, y equals 1 over x. And as we can see, that looks like this. Goes here, and it goes here. It does not obviously cross the x-axis there at all, or the y-axis for that matter. But that's something that we saw in section 11.6. Now, they're relating that to the function y equals 1 over x minus 3. And y equals 1 over x minus 3, when we graph that on a graphing calculator, we get this. And this one certainly does cross over this y-axis here. But what I want you to notice is that there is a certain line, a vertical line, that it will not cross over. It goes down and then comes back down again, similar to what this original function here did on this y-axis. Now this function does it at the x value of 3. So x value 3 is a vertical line here that function is not allowed to cross. Okay? And what I also want you to realize is, if we talk about the excluded value of this function right here, we take the denominator and say x minus 3 cannot be equal to 0. That means x cannot be equal to 3. Okay, so notice that this value corresponds to the vertical line that function is not allowed to cross. Okay? So all this means is that by doing x minus 3 instead of 1 over x, 1 over x minus 3 instead of 1 over x, we've shifted that entire graph to the right 3 units. Okay? Notice that this graph here, 1 over x, approaches both axes but does not cross either one. Okay, so that's what is known as an asymptote. An asymptote is a line on a graph that a function approaches, gets very, very close to, but is never actually allowed to cross. Okay, so in this function here, our two asymptotes are the x-axis, again, we never cross over the x-axis. We're really close to it, and then we're really close to it over there, but we never cross. So the x-axis is one of our asymptotes, and the other is this vertical line at the x value of 3. So x equals 3, and the x-axis are the asymptotes of that graph. Okay, so asymptotes are lines on a graph that a function approaches but is never allowed to cross. I'm not going to make you graph functions in your practice problem set today, but I am going to ask you to identify vertical asymptotes. So vertical asymptotes means the vertical line, and those should always be written as x equals, okay? The equations of vertical lines are always written x equals some number. X equals something. X equals, I'll say k. K can just be any number it wants to be, okay? K means any number. So this function here, 5 over x plus 2, well, in this situation, my excluded value would tell me that x plus 2 cannot be equal to 0, which means x cannot be equal to negative 2. So my vertical asymptote of this function then is exactly that line. X equals negative 2. So the excluded value, this is my excluded value, and this is my asymptote. And they're really the same number. My excluded value says x cannot be equal to negative 2. My asymptote is x equals negative 2. Okay, one other thing that we need to look at is, instead of having the function be sliding right or left by putting something in this denominator here with 1 over x, if we add 3, or add any number onto the end of that function, 1 over x, or 2 over x, or 7 over x, or whatever it is, we've shifted that entire function up in the y direction, which means now, as we can see here, we are going to cross over this x-axis. But there's a line still that we will not ever cross, and that is right here at y equals 3. Okay? The reason that that line is at y equals 3 is because we moved the entire function up 3. And usually that line is at the x-axis, which means y equals 0. But now when we move the entire function up 3, then our horizontal line, our horizontal asymptote moves up that many units as well, from y equals 0 to y equals 3. Okay? So as a summary, vertical asymptotes should always say x equals a number. Horizontal asymptotes should always say y equals some number. Okay? Now, when we are identifying vertical and horizontal asymptotes, when we see a function like this, y equals some number over x minus something plus something at the end, the number down underneath the fraction with the x is our vertical asymptote. That's our excluded value. And then our horizontal asymptote is wherever that value is at the end of the function. So here's what I might ask you to do. I might ask you to find the asymptotes of this graph. F of x equals 3 over x minus 1, all of that minus 2. So if I deal first with my excluded value, I know that x minus 1, the bottom of that fraction, cannot equal 0, which means x cannot be equal to 1. Okay? So my horizontal asymptote is at x equals 1. Okay, that comes right from here. My vertical asymptote is at this number right here, because I've taken this whole function and I've dropped it down 2 units in the y direction. That's what that minus 2 means. So instead of having a horizontal asymptote on my x-axis, y equals 0, I now have a horizontal asymptote at y equals negative 2. Okay? So this number is whatever number is at the end of my function. Okay? So I would like you to try this problem. Find horizontal and vertical asymptotes of y equals 5 over x plus 4 plus 3. Go ahead and find the horizontal and vertical asymptotes of that function. Pause the video, take a look there. Then come on back and we'll wrap this up and I'll show you what we should get. The horizontal asymptote here is at x equals, the vertical asymptote, I gotta switch that backwards on the last problem, my apologies. The vertical asymptote is at x equals negative 4. The horizontal asymptote is at y equals positive 3. Let's go back up and change that up here. The horizontal asymptote, that's not the horizontal asymptote, that's the vertical asymptote. Vertical asymptote is there at x equals positive 1. The horizontal asymptote is at y equals negative 2. My apologies there. Horizontals are always x values. Horizontals are always y values. Verticals are always x values. If you have further questions about identifying asymptotes of the graph of a rational function, meaning lines that it's not actually allowed to cross, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.